Hello and welcome to the Tech Lunch Podcast, where we encourage our listeners to learn something new about tech every week. This can range from learning about new and exciting applications to the advancements in coding and technology. If you are always learning, you will always be a step above the rest. Take the time during lunch or during a break to listen and learn, kind of like a lunch and learn, but for the ears. This podcast will open the listener's ears to new and exciting technologies they may have not been purview to in the past. These topics will range from manufacturing technologies to data collection technologies and everything in between. Hello, I'm Nick.
Hello, I'm Ed.
And this week we're going to kind of touch on a little different topic, but one of the same that we've been talking about lately is automated ground vehicles, or AGVs. You know, when you think about AGVs, you're talking about a little piece of equipment that's moving logistical material from point A to point B and back again, or that follows a predetermined route around around a certain point. But when you think about AGVs, you got to also think back to the previous episodes we did. We talked about MQTT because they all talk the same language. So, when we're talking about AGVs, Ed, what kind of comes to mind when we're thinking about AGVs?
So when I think of AGVs, the first thing that comes to mind is material handling and machine tending. Now, leverage those technologies with MQTT and IIoT and digitalization across the automation stack. Now you can take advantage of increased accuracy, efficiencies, and productivity.
Yeah. And the thing is, when you're thinking about it, you take all those things, the stuff that we've already talked about once before in the earlier episodes, but all of those, different topics are controlled by essential, communication software set. So as AGV moves down the path, it sends signals back to the software stack that tells it, hey, guess what? I'm charging, or I'm parked, I'm loaded, or I'm moving. And most times that visualization topic that we've talked about in the past is where you would track that AGV and how it's moving across the shop floor or inside of a warehouse environment, or even as a forklift pulling material in and out of trailers.
So typically in a loading application, the operator takes raw materials, then load those parts into a machine to produce finished goods. But human error can play a big role that could produce scrap or even worse, line stoppage. However, with AGVs and MQTT and IoT and digitalization deployed across the OT environment, it has been shown in some cases that picking accuracies can be up to 99%. Average units picked per hour can be up to 85%, and onboarding hours can be reduced from 72 hours to 6 hours.
Yeah, if you think about it, with an AGV, well, one, you don't have to have it. It doesn't have to have lunch. It doesn't have to do anything like that. It just has to charge. But now if you're talking about a material retrieving AGV or robot or however you want to look at it, most of the time AGV, it's a vehicle that goes to a rack and picks a pallet or a palletized piece of equipment off that rack and brings it back to the point of consumption. However, if you're talking about, small material handling robots, flat-based robots, or AGVs, you have to have a racking system on top of it where the employee will actively pick the material and load it onto the AGV to be sent to the line side or to the packing location or whatnot. And that kind of goes back to the human-machine interface and the human-machine interaction, where that machine is sitting there waiting for you to do something to it and you trigger it to leave. So, when we're talking about, HMIs, which HMIs, if you're thinking about it from an automation control standpoint, you're talking about a screen where you could hit a bunch of buttons. However, from an AGV standpoint, we're talking about how the human and the machine kind of work together.
And then another thing to consider is path planning. We can use path planning with the AGV and MQTT and IoT and digitalization and use the different functionalities of these protocols across the automation stack and calculate milk runs for raw materials to be delivered to the shop floor just in time. Also, if we need to make adjustments on the fly, all these things can be done real time via subscribing and publishing across these protocols to let the system know what's going on. We don't have to worry about mistakes because these things can now be calculated, sent to the cloud, and we can even leverage AI across these platforms to even make the systems more intelligent.
Yeah, it's funny. You kind of talk about the equipment on board. We're talking about the equipment on board. You're talking about, in some applications, you talk about a Raspberry Pi that's still used, attached to a drive motor. That drive motor moves the AGV forward, backwards, 360. Or you're talking about a complicated circuit where you have a programmable logic controller, a backplane, and a couple other things attached to high horsepower drive motors inside of a transfer case that moves back, forth, and around in circles, or all the way up to the fact of you have like the AGVs that kind of look like the packing robot, the package carts that they use at the airport.
And if you have a system where it's a lot of variations across the product, where there could be a lot of customizations put in place, this is a perfect system to have an AGV in place and use the digitalization or the Industry 4.0 protocols and technology to use the SCADA to send it to the MES system, to the ERP, and then back to the cloud, and make intelligent decisions on the fly. Not make decisions based on a list that may be incorrect. You're getting real-time data that can be accurately deciphered and accurately deployed onto the shop floor.
Yeah, it's also easier to take those and set them up for maintenance. So we know how many runs that those AGVs have on them before either the battery has to be replaced, or before the motor has to be serviced, or even the control unit needs to be taken a look at. It's a centralized control system that can control thousands of AGVs, at any point in time, that will talk back to the main hub. But that also, like what you said, it goes back to the Industry 4.0 mentality of where we're making smarter environments. And, that goes back to another, little sidestep is the environment. The environment that these things can run in. AGVs can run in more austere environments than, humans can. They can do events that, humans just can't do because of the fact that they can do repetitive tasks without injury. Moving a pallet back and forth until, the end of the shift, saves the human from having to walk that pace and wearing the human out. It's one of those things of where, the use of technology to benefit the human. So the human and the AGV are kind of working hand in hand, side by side in the same type of environment.
And the thing I would like to piggyback on what Nick said, it's when we start talking about preventive maintenance and proactive maintenance and predictive, all these things can be leveraged across a client and broker where we publish and subscribe, and we can even publish and subscribe across those same nodes. So I can have set points that have thresholds that can be sent to a subscriber that publish back to a publisher to say, hey, your set point is now this. So you get a lot of dynamic interaction between these systems. You get dashboards that can be looked at in real time, and decisions can be made by upper management when we have to be flexible, when we have not ideal conditions for production, when we have downtime that affects our production cycle. All these things can be incorporated into these platforms like MQTT, through SCADA and MES and ERP and through the cloud and a little bit of AI on top of that. And then you have a histogram to go by.
Yeah, that's when you kind of look at the stack, or the AGV stack. You have the AGV at the lowest level, then you have the highest level or the medium range level where its communication, node, that Raspberry Pi or the PLC or however you want to look at it, talks via MQTT to a server. That server sends it via Kafka interface, and then they send that Kafka interface back to its web interface into its database and actively pinpoints that vehicle on the map. Is it moving or where's it going? How's it following the path? after you preset your locations on the map of where that AGV is supposed to go. Now, when you talk about the publish and the subscribe method, you can have a button on the shop floor that when you hit it, it sends a message to the AGV that's at that location and says, hey, guess what? Go to this location. Move there. So you don't have to always program the routes statically. You can have the routes programmed kind of on the fly. You can say, take this route and go that way, do this route and go that way.
And what we mean by predictive, we mean we have data points that are being analyzed. When it reaches a certain threshold, we say to an AGV that's close to time to be maintenance or needs some service, we can take this AGV and send it to a docking station and take the unit that was previously in the docking station that was getting service and send it back out. So what you do is you reduce the amount of hours that you use the equipment by using predictive methods. And then you can be proactive. You have to be predictive first, then proactive, and then you can be preventive. So everything is based on data points. So if you can get these data points and analyze what's going on with these data points and be predictive in nature, so you can be proactive when you have the anomalies, so that you can be preventive when it comes to downtime.
So you're talking about like a hot swappable AGV system. You bring one in, send one out, and all you do is send it back on a certain route that you want it to go on. That's pretty much what we're getting at here. And the thing is, AGVs, they're a very simple, application, very simple piece of equipment. Unless you start getting to the bigger tuggers and the big boys. When you're talking about like the forklifts, the pallet jacks, and all the other fun stuff that some of these companies are coming out with. You start looking at companies like SafeLog or AGVE or any of those other main companies out there, that are building these AGVs for use inside plants. Most of them these days are coming standard with MQTT, so there's no reason why not to leverage it. If you don't leverage the material and the equipment on board, you're already one step behind your nearest competitor. And that goes for anybody. If you think about it, if there's a way to use it in like a Walmart, for example, you're moving, goods around in the back side of a Walmart, why have a human on a forklift? Have the AGV do it if it's going to be the same process over and over and over again. Or, you do this to the subscribe and publish method, where it's, hey, go get this from this rack. It goes out there, picks it up, brings it back to the point of origin. If you think about it, we've all seen the videos of what Amazon does in their warehouses. 95% of those things are AGVs. Just following the paths. That's all they're doing.
And then there's another benefit, or I would say a very, very good advantage. It's safety. Most of these, the new AGV technology is inherently safe. It's built in with different detection devices. It's built in with sonar technology. It's built in with laser detection. Mm-hmm. It's built in with avoidance. So this is another thing. And also, we don't have to worry about fatigue, or we don't have to worry about not concentrating or being distracted, because an AGV is going to do what it's told to do, whether it's a magnetic strip, whether it's wireless, in an inside GPS type system, whether it's laser, whether it's ultrasonic sound, whether it's confined to some type of detection system where we use some type of laser scanner. So these things are built into the system. Also, we can also monitor those things and see where we had near misses and adjust our fields or adjust our protocols we had in place, just in case there's a situation where a human found a loop or a hole in our system. So this is another good thing. And the other benefit of this is not only can you do the safety things, I can also look at the efficiency of the paths. Maybe it's better to go this route as opposed to that route. So these are things that you can track through the MQTT, IoT, digitalization across the automation stack, and leverage those things to make the company more productive.
Yeah. Now, when you talk about safety stuff, also, you're talking about the field scanners that are on these AGVs. Some of them use, if they're like in a stack environment, they're kind of they use themselves for crash avoidance. However, inside those fields, if you step inside that field, it's kind of like a light curtain. You step inside that field, that AGV is going to come to an immediate stop. It's it's going to it's going to stop, and it's going to sound an alarm that's going to drive you pretty much batty. Until you reach over, you hit the e-stop, and you send it on its way. Which that leads me to another step in the side of the safety curtain that you have. You have e-stops. If that AGV starts getting erratic, or starts doing something that the operator just does not like, that operator can reach down and hit the e-stop, and that vehicle comes to a complete nutter stop and will not move until the e-stop is released. Every time that is sent, it sends a MQTT message saying that the e-stop is hit, there's something inside its field of view, or, there's something that's blocking it from its movements. And that automatically triggers maintenance to say, hey, guess what, let's go take a look at this. It also triggers your logistics department to look at it and say, okay, cool. Do we need to adjust our travel lanes to be AGV only and not have humans involved? Where it's just a pull up, drop off, and leave, and humans don't walk inside that, that particular area in an effort to avoid setting off the scanners on the AGVs, causing a material handling downtime.
And then the other thing is redundancy. You can always use redundancy. We can also use partners schemes where we focus the work over multiple AGVs. We can also set up our own alarm philosophies where we can verify that this alarm is a legitimate alarm and this one is not. You want to continuously monitor. That's the great thing about Industry 4.0. Industry 4.0 is not going to transform your plant into some cyborg. What Industry 4.0 is going to do is allow you to digitalize your plant, allow you to go paperless, allow you to be more efficient, allow you to take inefficient processes and turn them into efficient processes, allow you to take data in real-time situations and make real-time decisions that affect the company or can make the company profitable.
Yeah. And AGVs is the great way to do that. Because you're now not having to worry about, waste of motion. And that's kind of a big topic. It's money is time, time is money. I know that's an industry standard conversation, but, waste of motion is just waste embedded in the process. It's a Lean Six Sigma methodology. However, with AGVs, there's no wasted motion. You load the machine, you send the machine down the way, and it does a job for you. So that leaves the operator the ability to start picking the next order to put the next order on the next AGV that shows up, keeping that fluidity of motion. And that's kind of how it goes. It's like if you think about it in different sports, more fluid you are, the better off you are, and the less effort it takes to get to point B. So if you're spending less money on fluidity of motion and you're getting more jobs per hour out of somebody or out of a process, and those AGVs are taking up the majority of the walking time that you would use, then you've now efficiently did more jobs per hour if you would have based on the time that you would have saved.
And then I would say another point to make is you can use cameras also, and we can build in quality by using the cameras. So we teach the AGV with AI, and the AI said, hey, this image doesn't match what I'm supposed to have. So the AGV stops the process and say, hey, there's something wrong. So the AGV allows no bad part to be produced. It does not send a bad part to the next process. And if one gets through, only one gets through. This is something that most companies fight with. A human error occurs, and it takes 20 errors or 20 mistakes before we catch the failure or the defect. You can build all this into the AGVs with a vision system and based on recognition of what's good and what's bad, what's in tolerance, what's out of tolerance, and the AGV itself can signal to the MQTT, IoT, digitalization, automation stack, through SCADA, MES, ERP, and all these things can be leveraged through dashboards, through management, or through the appropriate personnel that need to make a decision or need to correct something that's wrong.
Yeah, and if you think about it, AGVs can be used for tool return. If you have one piece of process where the tool has to travel with something and come back, AGVs are doing that for you. You're not having to do it yourself. So your tool returns there. Your movements are all there for you. It's something that you don't have to worry about. There's small pieces of gear that save so much time and energy. But, from the IT side, they're really not that bad. You're really only setting up a server that can talk MQTT, probably Kafka if you need it, which is Apache. And also, like a MySQL database or something like that on top of a front end. That's you program in-house. So, getting to that point of where you have complete visualization using a MQTT stack is there, and it's ripe for the picking, because everything is there. But that also goes back to logging, because now I can take my MQTT interface and go to a Kibana interface, and then I could take that and start graphing that out for my visualizations and utilize the logging standpoint that we talked about once before. So, pretty much with AGVs, you're using MQTT, IoT, IIoT, and also a little bit of logging and some visualization stuff that you got going on, depending on how you want to do it. Everything is up to the user standpoint. Nothing's always set in stone. Everything can be changed.
And another thing to think about is it's not just in industrial environments you can use AGVs. The same concept can be used with automobiles that can drive themselves. The same concept can be used with community or carpools and so forth. The same concept can be used with delivery of goods from a grocery store or a hardware store out to a person's car, and it puts it in the back of the trunk because we need to have non-contact delivery in case we're in a pandemic or epidemic and so forth. So these are also possibilities that you can use. It can also be used with the Roomba that you're using at your house.
I was getting ready to say that, yeah.
So, I mean, it's an endless amount of possibilities with AGVs. It's not just in an industrial environment, it's in commercial and it's in residential.
Yeah. Think about it now. You got the the Roomba, the mop, the vacuum cleaner. Just think it's your kids and just tools. So the only problem is you still have to pay the kids because they're the ones who have to dump the stuff that the Roomba brings back. So I hate to say it, you can't get free labor out of a Roomba. But it's there. But that is what is considered an AGV in a internal network system inside your house. So it goes off of waypoints that you program the darn thing. But I'll tell you one thing, that if that's your first interaction with AGVs, then do it. And now, I don't know if you've seen it, Ed, but Roomba, I think it's Roomba, is now selling the programmable versions that somebody can buy and actually program their own AGV. It's kind of like the robots that you can do in Lego, the Lego robots. Mm-hmm. So, and that's kind of what brings us to the point for, kind of what brings us towards the end of today's conversation is, look out and kind of see what you can do with like the AGV technology, what you can play with. It make that the robots that you can build with Lego and stuff like that, the Kinects, I think it is now. Mm-hmm. Now they have the Kinect things in schools, but for that, go out there and take a look and see what you can find. So, but with that, I'm going to let Ed kind of, end us on this today, but, keep learning and, keep having fun.
So, I'll just piggyback off what Nick said. Every day is a day to learn. Learn something every day.
All right. Y'all have a good one, and we'll talk to you next week. Thank you for listening to the Tech at Lunch podcast, where we hope you learned something about tech during your break or during your lunchtime. If you did, please give us a follow to prevent missing future episodes. If you have any ideas or something you want to hear or learn about, please send us a show idea to podcast@vulcanara.com. Hope you have a good rest of the day and continue learning.